Remote access VPNs enable users to work from remote locations, such as their home, a coffee shop, a hotel, and so on. There are two main types of remote access VPNs, those being clientless and client-based. Clientless are typically achieved with a web browser portal, where users log in to the VPN, which typically uses the SSL protocol. Client-based requires an additional software client to be installed on the end device. We're going to look here at using a client-based SSL VPN for a remote access solution. Specifically, we're going to use the Cisco AnyConnect VPN client in conjunction with a Cisco ASA firewall, which is a very common solution in the Cisco world. We're also going to look at configuring this from the perspective of Cisco's ASDM, the Adaptive Security Device Manager. We've used the command line interface for site-to-site VPNs, so I wanted to give you some exposure to the GUI interface in the firewall here. In any event, let's jump right in. If we go to the top menu in ASDM, under Wizards, there's a section called VPN Wizards. You can see we have the ability to do site-to-site, clientless, IPsec, and of course, AnyConnect VPNs as well, which is what we want to choose. All of the VPN wizards will present you with an introduction explaining a bit about the type of VPN that you've chosen. Let's click Next, and you'll see that we're asked to create a connection profile name, which I'm going to simply call AnyConnect. The VPN access interface is, of course, the outside interface. That's exactly what we want to use, and that's already in place. If we click Next, you'll see that AnyConnect can use the IPsec or SSL protocol. In this case, I'm going to choose only SSL, and below that, we're asked to choose a device certificate. I've already created a certificate, so we can choose this existing certificate in my case. If we need to create one, we can simply choose Manage and select the Add option, and we can walk through the options of creating a new certificate, generating a new key pair, and go through all of the steps of manual self-signed certificate creation. Again, I'm going to choose my existing certificate in this case, and next we're asked to provide an AnyConnect package, or a client image in other words. This will be the AnyConnect client software that clients will use to connect to the VPN. We can choose the Add button, and we can then browse the flash directory of the ASA, or we can upload a new client image. You can see that I have several versions of AnyConnect already in the flash memory. In this case, I'm going to choose the Windows version to test this out in my virtual machine. If that were not in place on the flash, we could simply choose the Upload button, and we could browse our local file system to locate that and upload a new package. I'm going to click OK with the Windows package selected. We see the flash file is being read briefly, and now we see the flash directory referencing the AnyConnect client image package. Next, we go to the authentication methods. We're going to leave the local option in place here, but also know that we have the option of using Radius, TACAX Plus, and several other authentication methods if you use those on your enterprise network. I'm going to create a local user in my case because I don't have an external authentication server. Username Charles, password Cisco. I'll add the user and then I'll click Next. Now we're asked to create a new IP version 4 or IP version 6 address pool. Again, if we have an existing pool in place, we can choose that option. In my case, I do not, so I'm going to select the new option, and I'm going to name that VPN pool, and I'll set the starting IP address at 192.168.50.10 and the ending address at 50.20 with a 24-bit subnet mask. So now when clients connect to this VPN, they're going to get an IP address in this pool range. Next, we can specify DNS and WINS servers along with a local domain name. Again, in the case of my lab environment, these are not necessary. Now, if we try to click Next, you'll see we have a warning stating that DNS servers are required for remote users if they're going to be able to navigate the network using fully qualified domain names. That's completely fine for us in this example, so I'll just bypass that. And next we see the NAT exemption option. This tells us that if NAT is enabled on the ASA, the VPN traffic needs to be exempt from this translation. So I'm going to select that option, and then we want to make sure our inside interface is correctly selected, which it is here, and we can choose our local network. I'm just going to leave the Any option in the local network and click the Next button to move on. Now we have a prompt letting us know that the client deployment can happen in two ways: the web launch option or the pre-deployment option. The web launch option means that when a user accesses the interface IP address of the firewall from a browser, they're going to be prompted to download the AnyConnect client that's required for VPN connection. This is typically the easiest way to do that. The pre-deployment option means that we would need to manually install the AnyConnect client package on each end device. Once we click Next, we'll see a summary of our configuration where we can see our profile name, the access interface, and everything else that we've configured. We can click Finish, and now we see a preview of the CLI commands that are going to be sent to the firewall. So this gives you an idea perhaps about why I prefer this method. Look at all the configuration lines that we would have to create in order to set up an AnyConnect Remote Access VPN. This is the entire output that's going to be sent to the firewall. So I'm going to hit Send. That will be sent over to the ASA, and we're taken back to the section for the AnyConnect client profiles. If we scroll down to the bottom, you can see our newly created AnyConnect connection profile. If we click the Edit button, we can once again see all of those configuration settings. Now, one last consideration I want to mention is setting up split tunneling. I want to show you how to do that in the ASDM. Split tunneling allows you to split out your traffic to send specific traffic over the VPN tunnel rather than sending all of the traffic over that tunnel. And that's important to save VPN bandwidth. So for example, if you have users who are streaming video or music while they're on a VPN connection, you don't want that traffic going over the VPN tunnel and taking up your bandwidth. You want to route only critical traffic that should be encrypted over that tunnel, sending all the other traffic out to the normal public internet. If we click the Edit button for our AnyConnect connection profile, and we go under our AnyConnect group policy and choose Manage, and click Edit on the AnyConnect group policy, under the advanced options, we see split tunneling on the left, where we can define the interesting traffic that we want to go over the tunnel interface, while all other traffic is going to be directed to the local interface of the machine. If we deselect the Inherit option under the policy, the default option is to exclude the network list below, so you can exclude specific networks. In my case, I'm going to instead choose the traffic that I want to go over the VPN tunnel by selecting Tunnel Network List, and then under the network list, we can identify which traffic will be tunneled over the VPN. This list contains ACLs. You can see that I already have an ACL called Split in this case. I'm going to choose that ACL, and I'm going to select Manage, and what we want to do is to add an ACE, an Access Control Entry. This entry will define the interesting traffic we want to go over the VPN tunnel. In this case, I'm going to make that the outside interface network of the firewall. So I'm going to say 10.1.1.0/24. I'm going to click OK. I'm going to click OK once more, and I'm going to apply that to the firewall. And split tunneling is now enabled on the AnyConnect SSL VPN. So let's test this out. I'm going to pull up a browser in my Windows virtual machine, and I've gone out to the ASA firewall's interface IP address of 10.1.1.10. You can see our AnyConnect group that we created is populated by default. I can use the local user that I created to log in, username Charles, password Cisco. Since I do not have the AnyConnect client installed, this takes me through the prompts to download and install that client. We see a security warning from our self-signed certificate, and that's because I did create this certificate myself. Now, if we had a certificate in place from a trusted certificate authority, this prompt would not appear. Since this is a lab environment and we know that we created this, we can click Connect Anyway to bypass this. The client is downloaded and installed, and now we see the AnyConnect Secure Mobility client launched. Here I can put in the interface IP address of the firewall, which is 10.1.1.10. I can click the Connect button, and again we see the server warning we can bypass, and we're asked to log in with a valid VPN user account. And after some time, our VPN is now established. If we open the AnyConnect client VPN and we take a look at the settings and statistics, you can see we're using split tunnel mode. You can see the IP version 4 address for this client, which is the first available IP address in the pool that we configured. And if we go under route details, you can see that our secured route is the 10.1.1.0/24 network. So in other words, this is the interesting traffic that we configured to be tunneled over the VPN connection. The non-secure routes would be all other traffic outside of this range, and that would be handled by the local interface of this machine. So that's a look at configuring a remote access VPN, specifically a remote access SSL VPN using a Cisco firewall, Cisco ASDM, and the Cisco AnyConnect client.